Hello guys, in this video I'm going to explain you how to calculate slope of a linear demand curve or a quadratic demand curve and how to use the value of that slope in the formula of elasticity. So as you can see, the slope of linear demand curve Q is equal to A minus BP is minus 1 upon B. As it is a normal demand curve, we can first convert it into an inverse demand curve. Inverse demand curve, that is P is equal to A minus Q divided by B, or P is equal to A upon B minus minus 1 upon B into Q. Here 1 upon minus B is called slope. This is called slope of this demand curve. We can also do first order differentiation of this inverse demand function with respect to Q. That is dP by dQ is equal to minus 1 by B. Now the formula for calculating price elasticity is ED is equal to dP by dQ by dP into P upon Q. So if demand function is given to you in a normal form, then you can first convert it into an inverse demand function and take its first order differentiation. And you know first order differentiation, this is dP by dQ, and you can use it in the as an inverse demand function also. This is, you can use its inverse, that is dP by dQ also in the formula of elasticity as dQ by dP, and in the question they will ask to find elasticity at a particular price or at a particular quantity. They can ask in both ways. Okay, so the value of P and Q can be calculated easily. Let's do an example. So the question is, let's say, find out price elasticity for a linear demand function Q is equal to 10 minus P at P is equal to 5. So first of all, let's calculate the value of Q by putting P is equal to 5 in the demand function. It will give us Q is equal to 5, like this. Now calculate either dq upon dp straight away from the given function, or use it as it is in the formula of elasticity, that is ed is equal to dq by dp into p upon q. Or we can convert the normal demand function into an inverse demand function, p is equal to fd. This is also a question asked by UGC in one of the exams, that what is the form of inverse demand function, which is p is equal to function of quantity, that is d. Okay, this is the form of normal demand function. So now find its slope as dp upon dq and put it in the formula of ed is equal to 1 upon slope into p upon q. Now here slope, 1 upon slope is, this is slope of inverse demand function. Now I think you can solve this question. And how do you solve it? You can use the formula of ed is equal to dp by dq into p upon q. If you calculate dp by dq in the above question, then you will get dp by dq as minus 1, and the value of p is 5, q is also 5. You get the value of elasticity as minus 1, or you can say this is ed is equal to 1 unitary demand, unitary elastic demand. Now all these terms in the formula of ed can also be used to find out for a quadratic demand function. Now what is quadratic demand function? This can be in the form of like this, q is equal to 20 upon p, or any other form like this, p is equal to 16 minus q minus 0.5 q raised to the power 2. So let's solve some PYQs. of UGC NET asked in either 2017 or 2018. I beg your pardon for this correction. Now, this is the question asked by UGC. Given the demand function Q is equal to 20 by P, where symbols have their usual meaning, at which price the elasticity of demand would be unity? Options are 20 to 10, 5, or all of the above. Now, this demand function Q is equal to 20 by P is a special case of rectangular hyperbola. Now, what is rectangular hyperbola? I draw this diagram for you. You can see this diagram. This is convex to origin basically. On y-axis we take price, on x-axis we take quantity. This is rectangular hyperbola. Now, what's the property of this diagram? If you take any point on this curve and you draw a rectangle by showing combination of price and quantity, any point, like this first point is combination of P1 and Q1, the second point is combination of P2 and Q2, the third point is combination of P3 and Q3, and if you take area of these rectangles, area is length into breadth, that is P1 into Q1, area of rectangle remains the same. This is the property of this rectangular hyperbola, and the area of all the rectangles drawn like this will be the same, that is P1 Q1 equals to P2 Q2 equals to P3 Q3. Now, if you remember the total expenditure method or total revenue method, in which total expenditure does not change for any change in price if ED is equal to 1 for a unitary elastic demand. So, this is the case of unitary elastic demand, which is also given in the question. And if we solve it like this, then we can easily say that for all the values of price, the value of ED will be 1 only for all the price. So answer will be option D basically. So we can also calculate slope of this demand function, and then it will be in a different way. So the formula of ED is basically we have this: ED is equal to minus 1 upon slope into P upon Q. Again, this slope is slope of inverse demand function. Slope is slope of inverse demand function. Now, slope of this given demand function Q upon Q is equal to 20 upon B will be its first order derivative. Or you can also change it into inverse demand function, that is P is equal to 20 by Q. P is equal to 20 by Q. Sorry. And then you can calculate the slope of this P is equal to 20 by Q, which will be minus 20 by Q square. Sorry, this is Q raised to the power 2. I beg your pardon again. The formula of ED is minus dQ by dP into P upon Q, which is equal to, as per question, according to question, ED is unity. So we can say 1 is equal to, the inverse of slope is this, sorry, Q square divided by 20. This is the inverse of slope which we have calculated above, and into P upon Q. Fine. Now 1 is equal to, it will be Q upon 20 into P. I am ignoring the minus sign as well. So now, according to question, Q is equal to 20 upon P given to us. Now, by putting Q is equal to 20 upon P in this equation, we get 1 is equal to 20 by P into P by 20, or we can say 1 is equal to 1. Now, the 1 in the right hand side, we can write it like P raised to the power 0. I beg your pardon for this correction. This is P raised to the power 0 basically. I write it like this. 1 is equal to p raised to the power 0. This is p raised to the power 0, which means 1. So for any value of p, ed will be equal to 1. The correct option will be option D, all of the above. I don't know what UGC gave its like answer, but the correct answer will be D, all of the above. This is a special case of rectangular hyperbola, where at all the point of demand curve, ED is equal to 1. It shows a constant elasticity for any value of price. Now, another question asked by UGC was this. For demand function, P is equal to 16 minus, actually it is Q only, not Q raised to the power 5, minus 0.5 Q square. Now this has corrected now. P is equal to 16 minus Q minus 0.5 Q raised to the power 2. The elasticity of demand at Q is equal to 4 will be, these are the four options, 0.5, 0.2, 0.7, 0.3. So again, first of all, we calculate slope of this inverse demand function. This is basically an inverse demand function given to us, because it is in the form of P is equal to function of quantity. So the slope will be first order differentiation of this inverse demand function. So the first order differentiation of 16 will be 0, and of Q, sorry, it will be 1. So it will be minus 1 minus 0.5 multiplied by 2 into Q is equal to, which is actually minus 1 minus Q. This is the slope of this inverse demand function, minus 1 minus Q. If you have any query on this thing, how to calculate slope, then you can write to me in my email or in the comment box. I'll make a separate video on how to do first order differentiation of a power. Now the value of P at Q is equal to 4. You can get it by putting the value of Q quantity of as 4 in the demand function. You get this P is equal to 4, and then we put all these things in the formula of ED. The value of dq upon dp is 1 upon minus 1 minus q, which is inverse of the slope. The slope is basically dp upon dq, but in the formula of ED, it is dq by dp. This is dq by dp. I can also mark it if you want me to do that. This thing is basically slope of the demand function, inverse of the slope of demand function, sorry. And here now, by solving this, what do we get? You can see this is minus 1 upon minus 1 minus q into, this is, I write it like this, it is, we have minus 1 into minus q into 4 upon 4 into 4 divided by 4. So now you can solve it, and now we also put q is equal to 4 in the in this equation, and we get ed is equal to minus 1 upon 5. This minus 1 by 5, and we can also ignore this minus sign, then we'll get 0.2, which is the option B. So this is all about how to calculate slope, as well as how to use that the value of slope in the formula of elasticity. So I hope I have made it clear to you. If you have any doubt, you can email me, or you can write down in the comment section. I can make separate video if you want me to do that. Thank you for watching. Bye bye.